Okay, let's take a look at how you can solve quadratic inequalities. For example, you could have 3x squared minus 14x minus 5 is greater than or equal to 0. Remember, this symbol means greater than or equal. This just means greater than. So this does not include 0, but this does include 0. How would we factorize this? Well, first we can work out the x values for this equation when it equates to 0. So we can say 3x squared minus 14x minus 5 is equal to 0. Now it just becomes a quadratic equation, right? And we can factorize to solve it. The coefficient is greater than 1, so it's a bit confusing, but we have a method to do this, don't we? There's a method. I'll link the video that explains this down below. Two numbers multiply to make the last two digits, so that's going to be minus 15. Two numbers add, so what we're doing right now is factorizing this quadratic equation to find the x values. Two numbers add to make the middle digit, negative 14. What numbers multiply to make negative 15 and add to give us negative 14? Well, we've got 15 and 1, don't we? 15 times by negative 1, sorry, that should actually be negative 15 times by positive 1 will give us negative 15. Negative 15 plus positive 1 will give us negative 14. Like so. Yeah. And now we can just make our two equations that we can factorize. So the x squared stays the same. Then minus 15 becomes the second x. The 1 becomes the next x, so that's going to be 1x, and then the last number stays the same. We can factorize each expression. 3x, x minus 5, and this can become, well, just 1, right? 1 x minus 5. And you'll notice we get two brackets that have the same numbers in between. That becomes our factorized numbers. So x minus 5, and then the two numbers that are outside the brackets also become numbers. So x minus 5 and 3x plus 1 is the factorized version of 3x squared minus 14x minus 5. So we have x minus 5, and we also have 3x plus 1. So what we've just done is we've factorized 3x squared minus 14x minus 5 is equal to 0. So this is when it was equal to 0, right? Now I can just solve for x. So what would x be? Well, to be equal to 0, each of the brackets has to be 0 because then they would multiply to give us 0, right? So for this one, x could be 5. 5 minus 5 gives 0. Or x could be negative a third. If x is negative a third, it's going to be negative 1 plus 1, which gives 0 again. So x is either negative 5 or negative a third. Now this is when it was equated to 0, right? What we want to find is when it's greater than or equal to 0. What we can now do is we can draw a number line, if I can draw one. Like so. X negative 1 over 3 would roughly be here, wouldn't it? X is 5 would roughly be here, we could say. Let's extend this out a bit further. Now this is going to be like the x, if we have an x and y graph, it's just going to be the x graph. Negative a third and 5. Now our original inequality, let's write it down here, 3x squared minus 14x minus 5 is greater than or equal to 0. Now that we have two x values, we now have like three different sections, right? We have section 1, we have section 2, and we have section 3. I can never draw these like cool bracket things, but anyways, we have three sections now. This section is the section that's less than or equal to, so x is going to be less than or equal to negative 1 over 3 here, this small section here. Why did I use this specific less than or equal symbol? That's because our question is less than or equal. If it was just less than, this would just be less than here too. Kind of makes sense, right? This section is between negative 1 over 3 and 5. So x is going to be in the middle, and x is greater than or equal to negative 1 over 3. So this is including negative 1 over 3. And it's smaller than or equal to 5. And our last section is x is greater than or equal to 5. We now have 3 different inequalities. We can now choose a value that fulfills each inequality. So that's going to be an x value that fulfills each inequality, right? And we can sub it into our original equation. If it fulfills this inequality too, that's going to form a part of our answer. If it doesn't, it won't. I'll explain that right now. So we have x is less than 1 over 3, right? For this, we could choose an x value of 1 over 3, but that's going to be a bit hard to calculate. So let's say x is 1. Sorry, it has to be less than. X is negative 1. This meets this inequality because it's smaller than negative 1 over 3, right? Now let's sub it into the big equation, the actual question, and see if it fulfills it. Well, if x is negative 1, it's going to be 3 times negative 1 squared. We're subbing this value into this inequality. Minus 14 times negative 1 minus 5. If we solve that, negative 1 squared is 1. So 3 times 1 is 3. Minus 14 times minus 1 is going to be positive 14. Watch your symbols, that's why you write it all out. And we have minus 5. If you solve that, what do you get? 3 plus 14 is 17. 17 minus 5 is 12. Is 12 greater than 0? It is. So this does form a part of our equation. So that means this will form a part of our equation. How about our second one? Greater than negative a third and less than 5. How about we choose x is 0? That's going to be the easiest to calculate, right? And it's greater and less than 5. So perfect. Let's say x is equal to 0. If x is 0, these are all going to be 0, so we'll just get minus 5. Is minus 5 greater than or equal to 0? Minus 5 is smaller than 0. So this does not form our inequality. So this is not going to be part of our final answer. Let's try the last one. X is greater than 5. Let's just choose x is 5 for simplicity's sake. If we sub it into our original equation, 3, 5 squared, minus 14 times 5, minus 5. 5 times 5 is 25 times 3 is 75. Minus 14 times 5 is 90, no, 70. Minus 5 again, what does that give us? 75 minus 75, that's going to be 0. 0 is greater than or equal to 0. So this does form a part of our answer. So this is also going to be part of our answer. So our final answer for this question is going to be x is less than or equal to negative a third, or x is greater than or equal to 5. And that's how you solve quadratic inequalities.